Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, you've got everything you need to run a fast, reliable, and bulletproof data platform. And for your machine learning workloads, they've got dedicated CPU and GPU instances. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You monitor your website to make sure that you're the first to know when something goes wrong. But what about your data? Tidy Data is the data ops monitoring platform that you've been missing. With real-time alerts for problems in your databases, ETL pipelines, or data warehouse, and integrations with Slack, PagerDuty, and custom webhooks, you can fix the errors before they become a problem. Go to dataengineeringpodcast.com/tidydata today and get started for free with no credit card required. Your host is Tobias Macy, and today I'm interviewing Sijie Guo about the current state of the Pulsar framework for stream processing and his experiences building a managed offering for it at StreamNative. So, Sijie, can you start by introducing yourself?
Hi everyone. Thank you for having me on Data Engineering Podcast. And my name is Sijie Guo, and I'm currently the CEO and co-founder of StreamNative. StreamNative is a San Francisco-based startup, and we are providing a cloud-native event streaming platform powered by Pulsar, and we're also managing a fully managed service of Pulsar on different public cloud. And the managed service can run either in our cloud account or in our customer account. So, yeah, thank you for having me here.
And do you remember how you first got involved in the area of data management?
Yeah, so I was starting my kind of journey working on the distributed in cluster file system. And about 10 years ago, Hadoop was gaining the attractions in China. I was kind of the first set of the contributors who contributed to Hadoop, HBase, and Hive. And I was part of the initial team who built a Tencent data warehouse based on Hive. And Tencent is one of the largest internet companies in China. And then after working on a Tencent data warehouse, I moved my career to Yahoo. And that's why I get involved in a lot of development on Bookkeeper and later on Pulsar, and that getting into the whole messaging and streaming space.
And the separation of the storage from the broker in Pulsar is definitely one of the things that I find most interesting about it from the architectural perspective. And I know that Bookkeeper is being used for a number of other systems as well. And for people who are interested in more of the sort of background and early days of Pulsar and some of the architectural principles, I did interview a couple of the other core committers to the project a couple of years ago, so I'll put a link to that in the show notes. And for anybody who hasn't listened to that, can you just give a bit more of an overview about what Pulsar is and how you first got involved with the project?
So Pulsar, we usually use kind of one sentence to describe what it is Pulsar. We usually say it's a flexible Pulsar messaging that is backed by a durable log storage. The first part of the sentence is basically describing what are the kind of a core capability providing by Pulsar. It's a Pulsar messaging system. So you can use use Pulsar as a normal messaging system, like what you use for Kafka or use for RabbitMQ and ActiveMQ. But the second half of the sentence is basically tell the difference about like how Pulsar is different from many other messaging system. It's backed by a durable log storage, and the durable log storage is basically the Bookkeeper project you mentioned. And as you can see, what I was kind of the first engineer who was involving in the Bookkeeper project. So Bookkeeper was originally started in Yahoo Research, and it was designed to addressing the high availability issue of HDFS name node. So the core mechanism or core replication mechanism was abstract out of the dispute consensus algorithm that used by Zookeeper. And then it get evolved into distributed log storage, so that you can use the flat for building out many different systems. At that point, I think maybe 10 years ago, we tried to build the first PubSub mastering system based on Bookkeeper, which was called Hedwig. But right now, that project was kind of already deprecated. But that is basically set the foundation of the whole architecture of Pulsar or many other followers in this space. Is basically separating the broker serving from the master storage. So you can have two separate layers, individual layers that you can scale up independently. And also improving a bunch of the high availability and also fail over time. And I actually wrote a bunch of the articles a few years ago about talking about the architecture advantages of this layer architecture in segment-centric storage. And feel free to check out those articles in the internet.
And in terms of the overall lifecycle of data, where does Pulsar fit in that overall ecosystem of the different data tools? I know that it is sometimes compared to Kafka or also maybe used in conjunction with or instead of things like Spark Streaming or Flink. I'm wondering if you can just give a bit more of a picture of sort of the different ways that Pulsar is being used and some of the use cases that it's optimized for.
So I think to get started there is I'll try to actually maybe clarify a bit about the capability of what capability that Pulsar provide. As I said, originally Pulsar is flexible PubSub mastering system, so it offers all the capabilities of a mastering system. But after Pulsar is incubated in Apache Foundation for about 2 years, and that kind of get evolved into a more mastering plus streaming system, what we usually call it a cloud-native event stream platform. What does that mean is the core abstraction within Pulsar, it's kind of a distributed log. It's event streams. It can be used for storing infinity streams of events. And so the capability providing by Pulsar is actually you are able to using Pulsar to ingest events to topics. You are able to keep the event for a longer duration based on your retention policy, and you're able to using different data processing tools like you can integrating with Spark and Flink to do unified data processing. You can use Presto or Hive to do these interactive queries, and we also introduce Pulsar functions to lightweight computation. With that being said, is from the role in the whole ecosystem, first is since it's able to providing the ingestion capability for people to ingest data into Pulsar. So you can use that as a messaging system to connect the service with your whole data infrastructure. So it would become a kind of integration platform. And since we provide the capability for storing events for a longer duration, so you can use that for as a stream storage. And in my opinion, it's more like it has been evolved and became a kind of a streaming database because it provides schema, so you can treat those event streams as a structured event streams. And when we do the integration with Flink, we actually map these topics into tables in Flink catalog. So then you're able to use those data processing engine to query and processing data. So in short, to summarize, this is it's a messaging platform that you can do data ingestion, and it's I would say it's the stream storage that you can use for data processing. So that is kind of the idea.
And the functions capability that's built into the Pulsar project is definitely one of the things that I think makes it stand out in terms of the ways that it can be used, because I know that, for instance, with Kafka, it has support for Kafka streams and the Kafka Connect plugins, which Pulsar has the I/O as its analog to that. But it seems that the functions capability is a bit more tightly integrated into the capabilities of Pulsar. So I'm wondering if you can talk a bit to that and some of the other capabilities of Pulsar that make it stand out from some of the other options that people might consider for this durable PubSub use case.
Yeah. So I think so. Pulsar project has evolved and changed over the past 2 years, and definitely function is one of the most attractive features that a lot of people love to use. So function is basically very lightweight computing, I would say, event processing framework that bring the whole serverless idea into event streaming. So you can write event processing logic using the language you like. Like you can write a function using Java. If you're a Java developer, you can write a function using Python, using Go language. So you can write the functions as you like, and you don't need to learn a new framework. It's just like for every engineer, the first thing you know is how to write function. So this would reduce the barrier for people want to add the processing capability to existing PubSub messaging system. And one of the reason is most of the, I would say about 50% of the workload that messaging a messaging system is used is basically for connecting service within the infrastructure. And in order to provide the easy way for people to do the logic function is definitely the simplest way, because you don't have extra dependency. You can just write your function as you want, and so you can submit the functions. So that is definitely it's a bit different from a traditional data processing engine, which we more focusing on those lightweight computing use cases like ETL, transformation, routing, and prediction, and maybe simple aggregation. So that is function. And besides functions, Pulsar has adding many features in the past, and I can share some of them. Like another one is the tier storage, and tier storage is basically providing ability to extend the core storage capability that providing by Bookkeeper into some much cheaper form storage system like S3, GCS, Azure Pulsar, or even HDFS on-prem. And so this would allow you to keep the data into the system in an infinity event stream form. So you don't need to I need to dump the data out of my messaging system and going into some other storage format. And since by providing tier storage, you are able to keep data for much longer duration. It actually providing a unified abstraction of your data, which is called the infinity event streams. And when you integrating this data model with Flink, then you can create a unified data processing stack. And that is kind of the whole idea behind that. And I can call out some other kind of the features like key share subscription. That is another interesting one. And also the protocol handler, and which is allow Pulsar to be able to plug in different messaging protocols. And those kind of the features are kind of driven by the use case, driven by the adoption of the community.
And what are some of the other characteristics of the community that has grown up around Pulsar that you would see as being distinct from some of the other streaming systems that are being used by people?
So probably in the past 2 years, Pulsar has been kind of community-driven, use case-driven, and what have been seen very successful. Most of the adoptions of Pulsar is coming from three main categories. One is existing RabbitMQ and ActiveMQ users. So that is more coming from building out the core applications, and that drives a lot of development of messaging oriented features like TTL, dead letter topic, and schedule messages, delay messages. Those are the features that are more commonly seen in the traditional messaging queuing system. And the second category is more driving by the, I would say, data processing use cases, like more integrating with Flink and integrating with Spark. And that introducing a lot of features like key share subscription, the tier storage, and columnar offloader. So be able to kind of providing an efficient way for your data processing engine to process the events within Pulsar. And the third category is more coming from IoT use cases. That's that I would say that is kind of leads the bond of or leads the creation of Pulsar functions. So it drives a lot of development around bringing the serverless or lightweight computing features into Pulsar, and that's how the community helped the whole Pulsar team or Pulsar PMC to materialize the whole project as a product.
And over the past 2 years, I know that some of the features that have been incorporated since the last time I talked about this project on the podcast are things like the functions workers, and I believe that the integrated SQL layer is new as well. And I'm wondering if you can just talk about how the overall growth of the data ecosystem and the focus on streaming as a core architectural principle of these systems has influenced some of the product direction and feature decisions that have gone into Pulsar in that time period.
You're not talking about the kind of streaming capability that influenced the whole the functionality development of Pulsar?
Yeah, just sort of how some of the recent trends in the overall data industry have influenced the decisions around Pulsar and the direction that it's taken in the past 2 years since I last had it on the podcast.
We have been observed like a two trend in the whole when helping people adopting Pulsar. Like one trend is kind of more happening on the data processing area, that especially the rise of the adoption of Flink, and as well as Spark is able to do both streaming and batch processing. And we find that the increasing of the use case like machine learning, deep learning, create kind of a challenging to the existing data processing stack is you need a processing engine that is able to do both batch and stream processing. Is all these use cases not just only need the historical data, but they also need the real-time data. They need to combine both historical data and real-time data into one data processing engine. And Flink and Spark already do a great job on providing an abstract API or unified processing engine. But there's a lack of the data management system is able to provide a unified data system for those engines to be efficiently processing those data. We found because Pulsar, the core abstraction that provided by Pulsar is an infinity event streams, and that leads us into creation of things like tier storage that is able to support this unified data processing stack. So that is kind of the first category. And the second trend we have been observed is with the rise of IoT use cases, connected cars, you will see a lot more and more edge data centers and more smart devices. And those devices are kind of collected. The events or data of those devices are collected in the edges. But edge doesn't have enough resources for people to process those events. And hence you need providing a lightweight computing engine and for people to like maybe just easily write functions to processing those events in the edge. So this kind of edge oriented or IoT oriented use cases has become the main driving factor of the creation and also the adoption of Pulsar functions.
One of the critical elements of the success of any piece of technology, particularly open source, is the rate of adoption of users and the overall ecosystem that grows up around it. I'm wondering if you can talk a bit about how the user community has responded to Pulsar and some of the barriers to adoption that have existed and the work being done to drive those down.
So I think, and in terms of like, so we graduate, so Pulsar graduated around like late 2018, and there has been a very wonderful year for Pulsar in 2019. Just a couple of the metrics is the number of stars is already double, and we have seen the Slack channel, the users of Slack channel growing from like 500 to right now close to like 1,700, and we see contributors going from like around 70 to like right now it's 250. So we see like kind of from different metrics, we see the community has kind of double or even triple. And from adoption size, we have been seeing a crazy adoption in 2019. And we see this happening in Asia, both Asia, North America, and in Europe. In Asia, we have one of the largest internet company, Tencent, is going into an all-in state into Pulsar. Basically, their whole billing platform right now is building on Pulsar. What does that mean is every transactions or every purchase that happening in Tencent's product is going to Pulsar first. And it has been like processing like tens of billions of transactions every day. And in North America, we also see Pulsar is being adopted in different industries. And we have a whole page about Power by page for people to check it out. And we also do a user survey. The PMC did a user survey kind of at the end of 2019. We published the survey report recently and to disclose the kind of the current state of the adoption and how people use Pulsar and what are their plan to grow Pulsar usage in the coming year. So feel free to check that out. It's available in Pulsar website, or you can go to StreamNative website to download the user report.
And I know that the Kafka ecosystem has grown up quite a bit because of the fact that it was one of the first movers in this space. And so a lot of the existing systems that might integrate with a streaming system already have capabilities for working with Kafka. And one of the projects that you and some of your collaborators rolled out recently is an addition of the Kafka protocol running on top of Pulsar. So I'm wondering if you can talk a bit about how that's implemented and how that fits into the overall architecture of Pulsar itself, and what you think are going to be some of the benefits of that to the Pulsar community.
Yeah, I think that is a kind of interesting question. I kind of missed in the previous question is still we have a very wonderful 2019, but still there's some barrier for people to adopting Pulsar because there's already existing messaging systems like Kafka as what you mentioned, and as well as RabbitMQ and ActiveMQ. Those are kind of written in the standard messaging protocol like MQP. Hence, we're still seeing a bunch of barriers for people to adopting Pulsar. And what we have been thinking about, like how we want to reduce the barrier for people to use Pulsar and enjoy all the features provided by Pulsar, like multi-tenancy, tier storage, and functions. And the first attempt we have done, and which is also tried by OVH Cloud, is trying to implementing proxy, and that is usually people would commonly try to do when they want to adapt a newer system to an existing system. So they will write a proxy and try to write some logic to transfer the wireframes from one messaging protocol to the other messaging protocol. But we found that is not a natural way to do, and there's a bunch of the overhead and challenges. And we kind of step back in thinking about what are the real value provided by Pulsar. So as I mentioned before, is Pulsar is actually a event stream storage. So the core abstraction providing Pulsar is an infinity event stream. In other way, it's called a distributed log. So, and Kafka is kind of building around the similar abstractions. It's also a distributed log. So we found there's a lot of similarity between Pulsar and Kafka. And we think that we kind of step back and think maybe what we should do is make Pulsar as a reliable and scalable event stream storage and allow developers to customize their own protocol or messaging protocol. This first would help people creating some adapters to fit into existing messaging ecosystem, and the other way would allow a developer to make any innovations of developing messaging protocols by leveraging the whole fundamental advantages provided by Pulsar. So we kind of introducing one framework within Pulsar, which is called protocol handler. The protocol handler providing a way for implementation of a messaging protocol to interact with the whole event stream storage of Pulsar, and this into the creation of Kafka on Pulsar. So we're basically using the protocol handler framework to develop a Kafka protocol. And that is a plugin So you can download a plugin and install to your existing Pulsar cluster, and your Pulsar broker is able to speak Kafka protocol. With this capability, your existing Kafka application or Kafka service, you don't need to change any code. You can just point your Kafka application or service a Pulsar cluster, then you are able to go. And we did the work by collaborating with OVH Cloud. And right now, Tencent is also trying to using Kafka on Pulsar. So they're going to make Pulsar as a fundamental messaging infrastructure. And so this would we would expect this would help in growing the community and reduce the barrier for people to trying out Pulsar. And I did a webinar with Pierre, who is the tech lead of OVH Cloud, a couple of weeks ago. The video is available in StreamNative website, as well as the YouTube channel. And for people who are interested in Kafka on Pulsar, feel free to check it out.
And because of the fact that you have this protocol handler layer in Pulsar and it opens up the possibility of adding new protocols, I'm wondering if there's any work being done to integrate with the open messaging specification that's being put forward as a common standard for different messaging systems to be able to interoperate more easily.
Yeah, so right now, what we have been working on is actually integrating with two other popular messaging protocols. One is AMQP, the other one is MQTT. AMQP is very popular in the traditional messaging world, and MQTT is popular in the IoT messaging workload. And so we hope that this would simplify a lot of use cases that they are kind of moving from existing traditional messaging queuing workloads from the IoT messaging. So that is kind of the one effort that we are doing now. And it's also a cooperation with China Mobile. So I think that the interesting things of doing this in open source is we are able to leverage work with a lot of end user to kind of deliver what the end user needs and be able to serve the best use cases. And going back to the open messaging protocol, I was actually involved into the initial creation of the open messaging protocol. Right now, I think open messaging protocol or standard is kind of still an API level standard. It doesn't get into the wire protocol layer. So we are kind of still pushing that effort forward. If there's any open messaging protocol coming out, we should be able to support that very quickly.
And another interesting aspect of Pulsar and its relation to Kafka is that there is a decent amount of overlap in terms of the use cases that it provides for. And as both projects are still very active and have large and growing communities, I'm wondering what you have seen as being some of the ideas that are being passed back and forth and some of the lessons that are being learned from each other's communities and each other's technical implementations.
Based on my experience on helping people adopting Pulsar is I see that Pulsar is kind of commonly used in two categories of the users. One is, I would say, more coming from data pipeline, data processing, where Kafka is mainly used there. And the other category is more coming from these online core business services or event-driven workflow. People are kind of more using the ActiveMQ or traditional messaging queuing system. And what I have been seeing here is the adoption could happen in either way. Like people can coming from the traditional messaging queuing and looking into Pulsar, because Pulsar is able to provide a scalability that it's more scalable than a traditional messaging queuing system. Some other use cases more coming from Kafka, and in the Kafka world is most of the pain points are coming from the operational, especially when you want to operating multiple clusters or want to scale beyond a certain point. You will see the operational pain points, and the adoption of Pulsar is coming from these two kind of different categories. But I see a trend is when people adopting Pulsar for maybe for their online business or online use cases, they are kind of pushing Pulsar into kind of data pipeline, maybe like data processing. If people adopting Pulsar for data processing, they might be pushing to this online service. I do see Pulsar is able to kind of emerging these two different ecosystem. Then this also leads into the kind of the enhancement or the development of both ecosystems. So with putting in that way is Pulsar is also learning like from different ecosystem how to address those kind of the issues that has been seen in the existing systems. And I do see in the Kafka ecosystem or Kafka community, people also looking into how to adopting the features or the architecture advantages they're providing by Pulsar. For example, I see Kafka community has been talking about tier storage for a while, and those tier storage idea was kind of originally brought in by Pulsar. So I would see that these two community was still kind of growing in their own way, but they would kind of continuing like learning from each other. That is kind of my take on these questions.
And then in terms of your involvement with Pulsar, you mentioned that you've been working on it for quite some time, and you were one of the co-founders of StreamNative, which was one of the early companies built around Pulsar and driving it forward in terms of its development and growing the ecosystem. And now you have founded StreamNative as a company to build a managed service of Pulsar and its own distribution. I'm wondering if you can talk a bit about some of the lessons that you've learned from StreamNative that have been most helpful in your current endeavor, and how you characterize your relationship with the project and the community at each of those stages of your career.
I think for the first question, I think working in StreamNative and trying to kind of helping people adopting Pulsar and seeing the project going is definitely a very wonderful journey. And I have learned a lot of lessons from that experience. Based on those lessons and also the experience of running StreamNative, especially in 2019, we have been really focusing on helping people adopting Pulsar and growing a community. And I think I would say the most important lesson that I have learned is to first find the project in community fit. What does that mean is you need to find why people need Pulsar and how Pulsar can address people's pain points. And that has to be working with those early adopters. And I would say in some time you need to work with those large internet companies because they have this influence and they have this scale to be able to help you verify that Pulsar is able to kind of support from small scale to large scale and into different industries. And the last thing I find it's super important is also to find the position of software in the whole ecosystem. And I really like the question you asked earlier is what is the role of Pulsar in the whole life cycle of data management? And I think that is the most important lesson I have learned when running my own company is you need to fit into the whole ecosystem. And if you can see in the past year, we have been doing a lot of integrations with Flink and with Spark because that is the fit for Pulsar in the whole big data ecosystem because Pulsar is the messaging system. You are able to get the data into the system. You are also a stream storage. You are able to keep data for a much longer duration. That is the advantage providing by Pulsar. And in order for people to be aware of Pulsar, you need to do the integration with the big ecosystem. And with those kind of experience, we kind of moving into a product-led growth strategy is mostly focused on customers and also from the community users to learn what kind of the requirements and also the use cases and how we can incorporate those requirements in the use case into developing the project and as well as adding the features into the whole product. So that is kind of the most important lessons I have learned in the past. And you asked the second question is, since I'm kind of vendor in this market and how I categorize my relationship with this project in the community in each role. And I think most important thing I want to raise here is as a project running in Apache Foundation, we kind of working in the Apache way. What does it mean is everyone in the project in the community kind of wear multiple hats. Like for example, taking me as example, I'm an individual that is acting as a PMC member and also a committer for both Pulsar and Bookkeeper. So I have to be giving out an independent opinions from a PMC and committer perspective, because when I'm talking to the community users, I'm representing the Apache Software Foundation. At the same time, I'm also the vendor of Pulsar, the owner of StreamNative. And so what we have trying to do here is we do a lot of things to try our best to helping people adopting Pulsar. It's more from a partnership collaboration perspective, because we believe we have to grow the community in order to grow any business built around Pulsar. With helping people adopting Pulsar, we get a lot of use cases that we can incorporate those requirements into developing Pulsar, and that in return can help growing the community of Pulsar. So I think it's we play multiple roles in the community, and we kind of developing those relationships in a collaborative way, and making sure the main focus of the project is on growing the adoption and making sure people is able to use Pulsar in different industries.
And I know that one of the ways that you're helping to drive that adoption is by being a spokesperson for the community. I know that you release the bi-weekly notes of what's been happening within the community, and you also have a StreamNative distribution of Pulsar to help simplify some of the operational characteristics of the system. So I'm wondering if you can dig a bit more into what's included in that distribution and some of the work that you're doing to help simplify the operability of the platform, because of the fact that it does have so many different moving pieces.
So I think from a StreamNative product perspective, we do provide a StreamNative platform, which is it's powered by Apache Pulsar. And currently the main difference between a StreamNative platform and the Pulsar is basically we're providing a lot of operational related tools for people to simplify the operations of people running Pulsar in different environment, mostly focus on the Kubernetes environment. So we provide Helm chart, we provide Golang-based the administration tools, and we provide Pulsar Manager, and we also offer an enhanced version of Grafana dashboard for people to really understanding what's going on into the platform. That is kind of the main focus for the first version of StreamNative platform. Besides that, is we also bundle kind of a Kafka and Pulsar natively into the platform. So for people who want to use Kafka and Pulsar, you can download StreamNative platform and get started easily. And at this moment, StreamNative platform is kind of purely community edition, so everyone is free to use. And we might be developing some of the enterprise more kind of closed source features in the future, but we haven't decided yet. Our main focus is still on developing our cloud service and providing the managed service in the cloud.
And I'm wondering what motivates you to dedicate so much of your time and energy to Pulsar in particular and the streaming data ecosystem in general, because a significant portion of your career has been focused around this project and this problem domain. So I'm wondering what is keeping you interested and motivated throughout.
Yeah, so as I mentioned, I think I started my career about like 10 years ago, and I see the kind of the how Hadoop and how kind of the infrastructure technology can grow and can influence the whole industry. Basically, the whole growth of the economy in China, especially on the whole internet industry, is kind of due to Hadoop and due to the whole big data ecosystem. So I have been seeing how a technology can influence a whole industry. And I moved from Yahoo to Twitter, and Twitter is kind of a messaging platform for the whole internet. And you can think about Twitter as kind of the first company who is kind of using a lot of streaming technology. So I get into this space, and I see how streaming technology can be used for helping an enterprise like Twitter to become very successful. And I want that kind of the technology or that kind of the streaming mindset to be delivered to more industry to help them successful in this industry. And we see some of the existing technology have that didn't address this in a very great way. There's still some shortcomings like drawbacks. So we want to kind of use our experience, use the technology that we have been developing to have it help more industry, more enterprise to be able to enjoy the power of streaming technology. And that's why kind of driving me crazy into this space and dedicate my energy into this space. Yeah.
And one of the interesting impacts of projects such as Pulsar and Kafka and the overall focus on streaming data as a core component of a lot of these data systems is that overall design is starting to leak out into other areas of software and technology. And I'm wondering if you could just talk about some of the ways that you have seen streaming data as being an important core competency of different technology industries and the ways that projects such as Kafka and Pulsar are impacting some of the broader software and data landscape and the ways that applications are architected.
So in terms of streaming, what we have been thinking about streaming is actually coming from we see a kind of a software usage pattern has been shifting within an enterprise. So initially, like an enterprise is more building out in a way of using software. So you might building out a team of people who is kind of working with a database, and then you put data layer, you provide some query interface for people to query, and that creates the whole database ecosystem, and that get evolve into this big data or batch processing ecosystem. But the use cases and also the requirements has been shifting from more event-driven workflow, like all these the events can be generated from different sources, like when, for example, like when you browsing a web page, you click on this web page, you are generating different click event. Those events can be used by the enterprise to analyze it and analyzing the user behavior and be able to do better targeting, better marketing, be able to providing better services. So we see the use case has been shifting to more an event-driven or streaming-driven use cases. And that means the whole software architecture for an enterprise has been shifting into an event-driven architecture or event-driven workflow. And in that way, the mindset is able to kind of shifting from processing static data set into dynamically changing data streams. So once you have this mindset shift, then you need new tools, you need new capability, and that creates the whole messaging ecosystem, streaming ecosystem, and streaming tool chains. And we see these kind of tool chains and the ecosystem has helping like from industries from like internet to financial to retailer and maybe to IoT has been very successful. But this can also be very useful and powerful to other traditional industries, and that is kind of that is why streaming data is playing a very important role in the current enterprise software architecture.
I'm wondering what you have seen as being some of the most interesting or innovative or unexpected ways that you've seen Pulsar used and the applications of streaming data.
Yeah, so I think the common kind of impression that the industry has on Pulsar is basically a master queue, and we have Pulsar users in China that is called Base Pay. Base Pay is the third largest payment companies in China. And the use case there is very interesting. Is they use Pulsar for their real-time risk control pipeline. And in the traditional data processing stack, is people usually using Lambda architecture. So you're building out a batch layer that is using HDFS or Hive, and you building out a speed layer using Kafka and Storm, and you combine these together into a Lambda architecture. The use case in base pay is basically they try to get rid of these two layers and getting into a unified data processing stack. In the storage there, they standardize on using Pulsar as the source of truth. So basically, they put everything into Pulsar, and so then you would have a common, I would say, a center that is keeping all these event streams, both for the historical data and also the real-time data. And they standardize the computing engine into using Spark. So they can do Spark structured streaming and also Spark. So they reduce the system from 4 to 2. And with these kind of converting shifting the whole capability of Pulsar beyond a messaging queue, it's becoming a streaming data warehouse. So that is kind of the most interesting and innovative way for using Pulsar in a use case. And I'm excited about this use case is because it's also using in real-time risk control that is in the core business pipeline that is really deliver significant impact to a business logic. So that is kind of the most interesting use case I have seen Pulsar has been used.
And for people who are adopting Pulsar, what are some of the edge cases or design elements that they are most challenged by in terms of figuring out how to architect and design their own solutions and use cases around Pulsar?
So I think one of the common pattern or common question I have received in the community is, especially coming from the event sourcing perspective, people has the impression is Pulsar is able to keep event data, and you are able to keep the events for a longer duration by leveraging tier storage. And but people kind of looking for more from a point lookup perspective. They want to use Pulsar as a storage for point lookup. But Pulsar is mainly designed for streaming workloads. In other way, it's more designed for a scan base. So you're kind of streaming data. You are able to processing the streaming data in sequence, or you want to rewind your data processing job to an earlier point and rescan the data. So Pulsar was kind of more designed in a way for scanning oriented workloads, not point lookup. So I think that is the common kind of mistake, misusage of Pulsar. And I would like people to be realizing it before making any design on Pulsar.
And for people who are evaluating Pulsar or considering it as a component of their architectures, what are the cases where Pulsar is the wrong choice and they might be better served with either an entirely different approach or a different set of tooling?
So if you are the point lookup as an event store, for sure that is kind of the first long choice. I don't think at this moment Pulsar is not capable for doing this operation yet, but it might be changing in future. Who knows? But at this moment, doing any point lookup in Pulsar is the long choice. And the second one is I see a lot of pattern is also coming up is Pulsar is able to support millions of topics. But so people would end up trying to mapping devices or users to an individual topic, and they try to grow the number of topics beyond maybe millions or 10 millions, and that is kind of still a bad. It is based on current Pulsar implementation. That is still a kind of a bad design. We should try to re-architect in a way to use. At least reduce the number of the topics that would be used by that single application. We definitely can support millions, but not tens of millions. And especially when you operating in millions of topics, it's still a bit challenges. So when design that, when people need to be trade off how to use Pulsar topics and how to leverage all the good features providing by Pulsar. And the last one I would say is more Pulsar also providing these non-persistent topics or non-persistent capability. And in order to use those non-persistent capability, people has to be realizing what are the delivering guarantees or dispatching guarantees to making sure you are not surprised by those guarantees providing by non-persistent topics. So those are kind of the three common pattern or common miscommunicate use cases I have seen in the community.
And as you look to the future of the business for StreamNative and the Pulsar project and community, what do you have planned and what are your goals?
Yeah, so in terms of the service or the product providing by StreamNative, we are kind of fully focused on developing StreamNative Cloud, which is the fully managed Pulsar service running on public cloud. We want to give people the first-hand experience, very smooth experience for people to get started in using Pulsar easily. And that is from product side. Project side is, as I mentioned before, Pulsar has been evolved beyond Pulsar messaging system. So you have three main capability is you're able to connect, like ingest the data into Pulsar. You're able to store data. You're able to processing data. So in terms of project side is we want on the ingestion side is we want to integrating with more messaging protocols for people to be able to integrate with the existing messaging applications. And in the storage side, we want to do more in the offloader, in the tier storage by bringing in some additional data processing oriented capability like columnar storage and bring in index and be able to leveraging topic compaction. So those functionality can helping Pulsar providing better performance for unified data processing story. And in terms of the processing side, we want to improving the Pulsar functions to introducing some orchestration framework to combine multiple functions into a pipeline. So people can write a simple function pipeline to chain multiple functions together. And we are also looking into integrating with WebAssembly that is able to easily to support different languages or functions. And in terms of integrating with Flink, we already make Pulsar as a source in sync for both Flink and Spark, and we make Pulsar as the catalog for Flink as well. And the next step is how we want to deal with the state management, and the state management would come both for the Pulsar functions and as well as Flink integration. So there's a lot of things to do regarding state management.
Are there any other aspects of the Pulsar platform and its community and the ecosystem that's growing up around it, or the work that you're doing at StreamNative that we didn't discuss that you would like to cover before we close out the show?
So Pulsar community was going to hold the first ever Pulsar user conference, Pulsar Summit, in April, and due to the increasing worst situation of coronavirus, we kind of pushed the user conference to August. But at this moment, organizers also exploring a different approach by providing a pure virtual conference for Pulsar Summit. And please follow us on Twitter, and we'll keep everyone on a post. We are very excited, and we are very confident we are able to hold a kind of virtual conference and to able to show more Pulsar-oriented use case to broader community.
Well, for anybody who does want to follow along with you for that or get in touch and see the other work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I would just like to ask a final question of what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think the biggest gap is I think right now still in the whole data management space or in the whole big data ecosystem, there's still many components in the whole pipeline, and the ability to kind of glue different type of the system together and also provide a uniform operation and also management experience. Like in other way, providing ability to trace events that is going through from data source all the way to the data analytics or data warehouse, that I didn't see there's a good tooling, and I wish in this space would like to see more efforts happening this.
Well, thank you very much for taking the time today to join me and share your experience working in Pulsar and building a business around it. It's definitely a very interesting tool and one that I've been exploring for my own purposes. So I appreciate all of the time and effort you've put into that, and I hope you enjoy the rest of your day.
Thank you for having me here, and it's my pleasure to share all the experience, all the knowledge around this project, and as well as the company. And if you want to chat with me more about Pulsar or in general about streaming technology, you can find me on Slack or Twitter. Yeah, thank you.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.